Okay, so starting a new chapter today. Those of you, anybody who scored pretty much lower than an 85, I mean, it's pretty easy to fix this one. Just come and find me. Like you should fix your test. Like, I mean, it's a multiple choice. You've got a great chance of doing that. Or just have a teacher who's allowing you to fix the test and then give a lot of attitude. I mean, either one. Either one.
I wasn't really thinking about that.
Just giving attitude to whatever you were thinking about?
No, I was thinking about something else.
Gotcha. Here we go. Page 172, 1 through 13. This is a lot of isosceles triangle stuff. Number one, if the measure of angle BDA, or actually the measure of angle BDA, if the measure of angle BDC is 90 degrees, therefore the measure of angle BDA has to be 90 degrees. If you don't have the degree mark, you're going to start missing points. Okay? Geometry is about the notation. 2, the length of AB, if BC is 10, AB is 10. 3, the measure of angle BCD, if the measure of angle A is 50, the measure of angle BCD is 50 degrees. The measure of angle A, if the measure of angle BCE is 132 or 125, where am I at? 132. The measure of angle A is 48. Number 5, the measure of angle ABD, if BD is perpendicular to AC and the measure of angle BCE is 125, then the measure of angle ABD is 35. And number 6, DC is 12. Are there questions on 1 through 6? Number 7, the measure of angle B is equal to the measure of angle C, which is 80 degrees. Number 8, if they're all the same, that means they're all 60 degrees. That is an equiangular triangle. All equiangular triangles are equilateral. Equilateral, equiangular triangles are called regular. Number 9, the measure of angle P and the measure of angle Q are 65 degrees. The measure of angle R is 50 degrees. You would set up the equation as x plus x minus 15 equals 180. Number 10, the measure of angle T and the measure of angle TVU are both 70, which means the measure of angle U is 40 degrees. Number 11, angle 1 is 26 degrees, angle 2 is 64 degrees. Number 12, the measure of angle 1 is 120 degrees. The measure of angle 2 is 60 degrees. And last but not least, what is the measure of each base angle? The base angles are the congruent angles in an isosceles triangle, and it is 70 degrees. Questions, concerns, and or problemos? Okie dokie. Here we go. One of my favorite units. Also, it's a lot of small things that if you forget one thing, it's going to screw you up for something else. It's going to screw you up for something else. You need to be on point in your note taking. I can't express this enough. I'm going to put some notes up here, but when we get to the back over there, you want to have a whole new page. I would turn your notebook sideways because we're going to have a big flow chart, and you're going to want to be able to write things on it. So you might want to wait for me to draw the flow chart, yeah, and then copy it down. I'll give you time, okay? So we are in chapter 6, which is going to be quadrilaterals. Okay, so we're talking about quadrilaterals. Today, specifically, we are classifying, which means we are going to be able to look at a figure and say, oh, it's this. We're classifying the quadrilaterals. Now, first off, what is a quadrilateral? Good. A polygon with 4 sides. Think quad, think four-wheeler. A quadrilateral. A polygon with 4 sides. It can be any polygon with 4 sides. So, most of us would look at this and say, what shape is that? Is there anything proving that? No, so it's a quadrilateral.
What would prove it to be a square?
Ah, we'll get there. What about that one?
That's a polygon.
Rhombus?
Oh, it looks like that, right? Is there anything proving it? So it's a quadrilateral.
I want to know if he proved it.
Okay.
It's a diamond.
Oh yeah, it looks like a diamond. Cool. It's a quadrilateral. They all have 4 sides. Even though they all look different, they all have 4 sides, therefore they are quadrilateral. Okay. So, here's what we need to know first. Some words. Okay. These are opposite sides. Just like this would be opposite sides. Everybody with me? Then those are opposite what? Angles. Okay. You're going to hear a lot about opposite sides, opposite angles. Then you're going to hear about these. These sides are next to each other, right? They're next to each other. Those are called consecutive sides. So those are consecutive. These are consecutive. These are consecutive. Those are consecutive. Consecutive just means they're next to each other. They share an angle. Okay? Everybody still with me?
Yeah.
Last but not least, I bet you can guess based off of what we've done so far. That's right. We have consecutive angles. 2 angles that are on the same side. So notice how this angle and this angle are on the same side. This angle and this angle are on the same side. This angle and this angle are on this. Okay, so consecutive angles. That's a kind of cool shape that I just drew there. Cool. Consecutive angles.
Star.
You need opposite sides, opposite angles. Consecutive sides, consecutive angles. Have I lost anybody yet? Good. Okay. Don't copy anything down yet. Ceiling. Let's see. Oh, I should bring this much closer. There we go. Okay. So, a flow chart says one thing leads to the next thing, leads to the next thing, leads to the next thing. So we're now going to be on this board. Don't copy this down yet. I'm going to tell you when and how to copy this down. So, quadrilaterals is everything that we were talking about. Any polygon with 4 sides, really anything with 4 sides, it will be a quadrilateral. If it has 5 sides, guess what? It's not a quadrilateral. It won't work. Everybody with me? Okay. Here's the key, and I'm going to talk about this a lot. Always goes down, sometimes goes up. Always goes down, sometimes goes up. No, I'm doing this wrong. Hold on. Always goes up, sometimes goes down. Shoo! What do I mean? So the next thing, and the thing that we will be talking about the most, is a parallelogram. Parallelogram. Don't start copying these yet. Just watch. A parallelogram is always a quadrilateral. That means, first off, what do we know about a quadrilateral? So what do we know about a parallelogram? If it's always a quadrilateral, what does a parallelogram have to have?
2 sets of parallel.
Stop. If a parallelogram is always a quadrilateral, what is a quadrilateral? Four sides. So what does a parallelogram have to have?
4 sides.
4 sides. Everything that's above whatever it is will have all of those attributes. So what really is a parallelogram? It has opposite sides parallel. That is, and if you go in your book to page 248, it kind of says that. So it really says 2 pairs of opposite sides are parallel. Well, opposite sides are parallel, so when I draw this, I have a parallelogram, and I have a parallelogram. So the opposite sides are parallel. Everybody with me there?
Yes.
Okay. Rhombus, rectangle. So now, here we go. A rhombus is always a parallelogram, which means a rhombus is also always a quadrilateral. So I'm not going to write this, but here's what you need to know. A rhombus has 4 sides. The opposite sides are parallel, but what makes it a rhombus? 4 congruent sides. That's what makes it a rhombus. So when I draw a rhombus, not only is it parallel, but all of the sides are congruent. Whew. So let's go to a rectangle. A rectangle is always a parallelogram, which means a rectangle has 4 sides. Its opposite sides are parallel. But what else? It has 4 sides because it's always a quadrilateral. So I say, if it's a rectangle, what else is it? Well, it's a parallelogram. It's a quadrilateral. Is a quadrilateral always a rectangle?
No.
No. I drew a bunch of quadrilaterals up there that weren't any of those. Is a parallelogram always a rhombus?
No.
No. A parallelogram might not have 4 sides that are congruent. Is a rhombus always a parallelogram?
No.
Yes. Always goes up. Sometimes goes down. Sometimes a rhombus is a rectangle, and we'll get to that. So what makes it a rectangle a rectangle? 4 congruent angles. Well, wait a minute, Mr. H. Wait, stop. If it has 4 congruent angles, what will be the measure of a rectangle? What's the angles in a rectangle? Y'all, what do the angles of a rectangle look like? What degree?
90.
There we go. They're right angles. Whew. Okay. The 4 congruent angles are right angles. Oh my gosh. Okay. Then we're not even close to being done. This is a square. A square is always a rhombus, a square is always a rectangle, a square is always a parallelogram, and a square is always a quadrilateral, which means a square, without writing it, a square has 4 sides. The opposite sides are parallel. It has 4 congruent sides, and it has 4 congruent angles. So what makes a square a square? The word and. 4 congruent sides and 4 congruent angles. A square has to have the congruent sides and the congruent angles. Are everybody still with me? Okay, that's its own thing.
It's like a family tree over here.
Yeah. Okay, then we have a kite. Kite is very different. Read what the kite says on that page. Consecutive pairs.
With 2 pairs of congruent consecutive sides, but whose opposite sides are not congruent.
So I'm going to say opposite sides are not congruent. Opposite sides are not congruent. Crud. Come on. There you go. Go away. Oh man. Oh man. Sure. Two pairs of consecutive congruent sides. So what's this going to look like? Those are congruent.
Yes.
These are congruent. But guess what? You ready? You ready? You ready? You ready?
Yeah.
What?
Wow. Wow.
Oh, actually, that's not true. That's not true. I don't like that. It could be, but I don't like that.
Wow.
I don't like that. Okay. So now we're almost done. One more. Well, actually, two more. So we know a kite's always a quadrilateral, and we know that a trapezoid is also a quadrilateral. What's it say for trapezoid?
Trapezoid, four sides.
No, what does it say in your book?
Oh,
Well, exactly one pair of parallel.
I was like, I don't have enough information.
Exactly one pair of opposite parallel sides. So a trapezoid, those are parallel. Then you've got one more. An isosceles trapezoid. An isosceles trapezoid is always a trapezoid. So it has exactly one pair of opposite sides, parallel sides, exactly one pair of congruent opposite sides. Now, this is just today.
Oh, geez.
What else will I be adding? Now, really, here's the thing. On this flow chart, you're going to be adding that parallelograms. Opposite angles are congruent. You're going to add that opposite sides are congruent. You're going to say that the bisectors are congruent. You're going to say all of these are going to get added to your flow chart. So, the reason why I wanted you to copy this is we're going to still be adding to this. You want to turn your page sideways and leave yourself enough room so that way you can add around the boxes. Do so now. Go ahead. So turn your page sideways. You want to have this flow chart. I promise you, you want to have this flow chart. This is what's going to make your life much, 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 much easier. So I would say like I'd make it big. Make sure that you can read it, that you can write. If you don't understand or you can't see something, because again, this board's a little like consecutive there, it looks funky, but go for it.
Here we go.
What type of sides is it? What does it say? Two pairs?
Four sides.
What was the question?
Two pair.
For what, the kite? Two pairs of consecutive congruent sides, opposite sides are not congruent. So kite is two pairs of consecutive congruent sides. I'm gonna give you about one more minute now, I need to keep going. Well, that's why I'm leaving it up there, so that's why it's on a different page. You'll be fine. Notice how there's no lines going from trapezoid to parallelogram, or parallelogram to kite, right? So a rectangle will never be a trapezoid. A trapezoid will never be a kite. There are three distinct trees that are happening there. Okay? They can't commingle. Last minute. Then we gotta transfer up to the front board. We'll leave that up there until the end of class, then that will get deleted and you'll have to watch it on the video. Okay, so you might have to come back to that. So focus on the front board now. You might have to come back to it. I know that some of you don't like switching up like that, but you need to switch up with me. So there's a word up here that you might not know. Convex means like what you two are doing with your gum. You're blowing it out. It blows out. None of the angles go inside. So a concave, think like cave where a bear hides. 1, 2, 3, 4. That is a concave quadrilateral. We're not, in nothing that we do are we going to deal with concave. Okay, at no point are we dealing with concave. So even though it says convex, and in your book it's going to talk about convex, think about it just as a normal quadrilateral, okay? What you're used to seeing with quadrilaterals. So what this means is every quadrilateral has an interior angle sum of 360 degrees. So I have this. Let's call this 90 degrees, 110 degrees, 40 degrees, and X. Is it a quadrilateral? Yeah, it's got 4 sides. Therefore, I can say 90 plus 110 plus 40 plus x, all of that equals 360 degrees. The 4 angles of a quadrilateral have to add up to 360. So 90 plus 110 is 200, so that's 240 degrees plus x equals 360. I subtract 240 from both sides. X equals 120 degrees. So the interior angles of a quadrilateral, have to add up to 360. Think about it this way. What do the interior angles of a triangle add up to?
180.
180.
How many triangles do you see?
2.
If this is 180,
Oh!
this is 180. 180 plus 180 is 360. Okay? So, with that same idea, you can find the sum of any interior angles of a polygon with n minus 2 times 180, where n, let me write this, I'll put a little note here, n is the number of sides. So if you can count the number of sides, you can figure out what the interior of the whole sum is going to be. So I'm going to go down here. Here's my example. Octagon. How many sides does an octagon have?
8.
So n equals 8. To find the interior, I'm going to do 8 minus 2 times 180. That's 6 times 180. And that should equal 1080 degrees. Is that correct? That's the total interior of a octagon. Okay? Questions so far? How are we doing? Okay, last but not least. And we've kind of talked about this. I'm going to talk about it again. The sum of any sided figure's exterior angles is 360 degrees. So when you look at a figure and it's talking about the exterior angles, so if I give you an example, I'm just going to draw a figure. I don't know what it's going to be yet. 1, 2, 3, 4, oh, crud. 5, 6. So exterior angle, exterior angle, exterior angle, exterior angle, exterior angle, exterior angle. 1, 2, 3, 4, 5, 6. We know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6 equals 360 degrees. Always. Questions? Okay, here we go. Homework. Haven't had a lot of homework lately. we're going to do page 252 numbers 1 through 18. More than I usually give, but some of them are looking at a figure going, that looks like this.
Yeah.
Okay? Questions? You have just over 10 minutes to get started. I would suggest going. Love you all. Let's rock and roll.